Good morning, everyone. My name is Abi Dubey. I'm a Hadoop and NoSQL architect in Oracle. And today we will look at deploying Oracle NoSQL database on AWS. We will set up a 3-machine cluster. It's a very simple process. You will see that you can set up this cluster in less than 5 minutes. So what is Oracle NoSQL database? It is an advanced key value database. The reason I say it is an advanced key value database is that we have added certain features, certain sophistications over a basic key value interface. So the basic key value API, you don't really care about the value, right? When you have to read or write a record, you use the key. Now in our key, the key is segmented into major and minor key, which gives you certain advantages such as data locality. We only use the major key when distributing data. And we also support transactions. So as long as the transactions are over the keys that share the same major key, it is fully supported. Then we have a JSON API. Okay, this is another way of describing the value. So remember, in the basic key value API, the database is not aware of what is in the value. With the JSON API, we can describe the value with a JSON document. And in this case, not only are the fields visible to the database, so you can query the fields directly, you can do aggregations inside the fields, but we also support schema evolution. So if your JSON document changes in structure, you still continue to read and write the data that was written with the older format. Then we also have a table level API. This makes the design of your database easier in certain use cases. With this API, you will create a table. These tables are a little different than relational. Remember that the table definition is just a metadata. It's something that we store as a metadata. It's not tied to the actual data which is stored in your database. So just as we talked about schema evolution with the JSON API, similarly we have schema evolution with the table API. You can change things like column names, you can add more columns, delete columns, and that will not affect the data that is sitting in the database. But with table level API, you can very easily design very complicated data structures such as nested tables, tables with arrays, tables with a parent and child relationship, and other things. So with that introduction, let's get into the tutorial for today. And for this installation and deployment, the key concepts that are relevant are topology, shards, replication nodes, and storage nodes. Let's go through these one by one. Shards are non-overlapping subset of your data. Okay. For example, if your data has 100 records and you have 2 shards, then each of those shards will contain 50 records. Number of shards is set automatically by the database. So this is what we call auto sharding. So you don't have to specify how you want to shard the data or how many shards you want to have. It's something that the database chooses automatically based on the number of machines you have in the cluster. And in doing so, in setting the number of shards, the goal is to maximize your write throughput. The driver, in our case, Oracle NoSQL database driver, has a partition map. Okay. So before we get to partitions, the driver uses a MD5 hash function to determine the hash bucket for your major key. Okay, we call these hash buckets as partitions. It's a static hashing, so the number of partitions is fixed. And we will see when we deploy the database, we will set a number for the number of partitions, and then this number cannot change. And it's a two-stage algorithm. What this means is the first stage is mapping the keys to hash buckets or to partitions. So in this example, we have 100 partitions. Okay, so your keys will be distributed across these 100 partitions. The second stage is mapping the partitions to the physical storage. Okay, so in this case, on shard 1, we have partitions 1 to 50, and on shard 2, we have partitions 51 to 100. The advantage of using a two-stage algorithm here is if you change your storage, you add another shard, you remove a shard, it does not require us to remap your keys. Okay, that mapping can stay as is. Now, each shard has at least 3 replication nodes. Replication nodes are logical, they are Java processes, they are responsible for reading and writing data. Okay, one of these nodes will be a master. So for each shard, there will be one master node and 2 replica nodes. Master nodes are responsible for writes to that shard. All the 3 nodes are responsible for reads to that shard. Now the next term is storage node. Storage node is equivalent to a physical or virtual machine. And in a production environment, this will usually be a physical machine with a CPU and disk. The number of disks can be specified in a parameter we call capacity. Okay, so in this example, this is one shard. We are using 2 machines for this shard. Machine 1 has 2 disks attached to it, so the capacity of machine 1 is 2. So storage node 1 has a capacity of 2. Storage node 2 has a capacity of 1. And therefore, when the database placed the replication nodes, it automatically places 2 replication nodes on storage node 1 and 1 replication node on storage node 2. The next term is topology, and topology is the overall layout of your cluster, okay, of your deployment. It includes data centers. So in this example, there is one data center, which is called West. It includes all the storage nodes, and remember, storage nodes are the physical machines. So in this case, there are 3 physical machines. It will tell you the replication node processes running on each machine. So each machine in this case is running 3 replication nodes. And then you can also see the number of shards. Number of shards here is denoted by this rep group or RG. RG is equal to 1, RG is equal to 2, RG is equal to 3. It means you have 3 shards, 3 subsets of the data. Okay, so with this terminology, let's look at the steps required to deploy Oracle NoSQL database. The first step is to create a configuration file. And this configuration file has various information such as the host, a port, a capacity of the storage node, memory requirements. This configuration file is used by the storage node whenever it is started. Okay. So after we have defined the configuration file, we start the storage node. Okay. So remember, storage node is the machine, right? So this is the basic machine. So each of these storage nodes is running a storage node agent process. And that is our second step. We start the storage node agent. Now, on this storage node agent, we configure the name of our KV store. This is like the name of the database. Then we deploy one or more data centers. Then we add the storage node to the data center. We deploy the administrative service, which gives us a web GUI to monitor our store. And we create something called storage node pool, and this pool is for resource management. Okay. Once this is done, our first storage node is up and running, is fully functional. At this point, we add the other storage node agents to the data center. Okay, so in our example with Amazon, we'll be adding 3 machines. So in this step, I'll be adding machine 2 and machine 3 to the data center. The last step is creating and deploying this topology. So this is basically the layout of our cluster. So in this step, we'll be saying that this topology has 3 shards. Each shard has 3 replication nodes. Let's deploy it. At this point, the data store becomes functional. Okay. So let's look at this in Amazon. These are the 3 machines, the 3 instances I have on Amazon. These are micro instances, very low memory, 600 MB memory, and 8 GB storage. Okay. So if you have set up a Amazon instance before, you will know that this public IP changes every time you stop and restart your machine. And then these machines also have a private IP. This private IP remains constant. Okay, so once I am logged into one of these machines, I can ping the other machines using the private IP. So the only configuration here, which is relevant to AWS, is if you go to your security groups, this is my security group that I'm using for my instances, ONDB. And for the inbound communication, I have to open all the traffic. Okay. So that's what I have done here. I've opened up all the traffic. Okay. So with that, let's log in to our machine 1. Okay, so a .pm file is the security, the key file that AWS sends to you when you set up your cluster. My AMI machines are Ubuntu, so that's why I have the username as Ubuntu. This username can be different depending on which instance you chose on AWS. Okay, so now we are logged in. Okay, I have already installed, so I have downloaded the KV store file, which you can do from Oracle's OTN page. Okay, just if you Google for OTN Oracle NoSQL, you go to this nice page on OTN for Oracle NoSQL database. This is a very informative page. You have comparisons against almost all other NoSQL databases here. Go to the download section, and then there's these zip files, right? So I downloaded my .tar.gz file on these AWS instances, and I unzip them. Now that's basically where we are starting. Okay. So let me log into all the 3 machines. Okay, so you can see here, like I have in my profile, in my dot profile, I have actually entered the internal IPs because these don't change. So you can see like the 3 machines have 64, 65, 66. Okay, so 64, 65, 66 here. Okay, so now we are logged in. Again, I've in my dot profile, I have two other variables which are kb root and kb home. Okay, so kb root is where the database settings are stored. Okay, so when we create a store, when we create a database, we insert records, the configuration file goes in kb root, and then all your data files go under kb root. Kb home is the location of the binary of the install. Okay, so you can set this up accordingly. For me, when I downloaded this database, kbc 2.1.57, so I unzipped it in this folder under home Ubuntu, and that is why my kb home is in this folder. You can have some different path as you want. Okay, so now going back to our steps here, right? So first step is create a configuration file. So I have a script. It's a one-line command, but I've just put it in a simple shell script, which I call reset kv. So let me just show you what is in the script here. Okay, so because I have this cluster set up and running, this has already a 3x3 a 3 shard install of NoSQL running. I'll remove everything. So I'll remove the database folders just to start from scratch. Okay, so we can do these settings from the scratch. So you can see that I'm removing this kb root folder altogether. Okay, so once I have removed this folder, I again create these directories, kb root, and then 3 directories for 3 different storage areas on this storage node agent. And then this is the command to create this configuration file. You remember, create a configuration file. So the command is make boot config. Okay, so the utility is make boot config, and then we pass certain parameters. We pass the location of the root folder here. We pass the host name, so this is the IP of this machine. We pass the port where we want to run NoSQL database. We pass an administrative port. This is to see the web interface for monitoring. This is high range. HA range means high availability range. Capacity, so I'm telling this storage node agent that the capacity is 3 so that the database can place 3 replicas on this machine. Memory and these storage directories. Okay, so it's a straightforward command. Utility is called make boot config. Once we run this utility, okay, so let's run it. Once we run this utility, see this config.xml, this is the file that got created because of this command. Okay, so if you see what's in this file, okay, so all the parameters that we just passed, right, host admin, HTTP port, storage node ID, memory, they just got put in this XML file. Okay, so that's what make boot config does. So let's do the same thing here on node 2 and node 3. Okay, so right now on all the 3 nodes, nothing is running, and we have just created the configuration file. Okay, we have deleted all the previous configuration file. In fact, we have deleted the previous database altogether, and we just created the configuration file. Now the next step is start the storage node agent. So again, this is a one-line command. It's just start kbstore.jar start. That's the whole command. I have put that command again in a shell script so that it's easier to run. And let's look at that script before we run it. So the script is called start SNA. Okay, so as I said, this is just one-line command, and what we are doing is we are starting we are running the program kbstore.jar with the utility start, and that's it. Okay, so this command will start the storage node agent. Okay, so we do it on each of the three machines that we have. Okay, all right. So now we can see, we can check, right, what happened. So we can look at the Java processes. So as you know, when we start the storage node agent, some Java processes should be running. So we can see here that this start process is running and there's a managed service which is running. Okay, so this storage node agent now gives us this capability of logging into the machine and doing some more interesting things. Okay, the same thing here. You'll see the same processes running on all the three machines. Okay, this is the one which we are interested in, right? Managed service. This means that now I can go and log in and do something else, right? Create a cluster, start a service, things like that. Okay, so now we come to step 3. All right, so now we'll be doing the bulk of the work, where we'll be naming our KV store, deploying a data center, adding the storage node, starting admin service. So again, I've put it in this file here, deploy one. Okay, and these are just one-line commands for each of these sub steps. It's just a one-line command, nothing complicated here. So the first thing is I'm telling the name of the store. I'm setting the name of the store. Okay, and just to make it easier, I'm actually setting the name in this KV profile file that I have, and I'm just passing the variable here. Okay, but you can hard code it here. So you can say name of the store is customer data, for example. The next step is deploying the data center. Okay, so again, the command is plan deploy data center, and then you pass a name of the data center, and then the replication factor. Okay, the replication factor means how many copies of data you want. So in the slides that we saw, the default is 3, and that's why there were 3 replication nodes in each of the shards. Okay, so once we have the data center up, we deploy the storage nodes to the data center. Okay, so here's the command again, deploy SN. This means deploy storage node to this data center. This is the data center's ID, DC1, and the host name and port. Okay, the next step is we start the admin service. Okay, because of this admin service, I'll be able to go on a web page and look at the store. Okay, and then for resource management, we have these 2 extra steps where we create a pool. Okay, this is a pool of the storage node agents. So I create a pool and then I add my storage node 1 to this pool. Okay, so let's run this, deploy. Okay, so I had some echo commands in there so that we know that everything is deployed. So we can see that the store was configured. The name I chose is my store. Then the first plan was to deploy the data center. So it says executed plan 1 successful, and this plan is data center west was deployed. Then the second plan was to add the storage node to the data center. The third plan was to start the admin service. Okay, and then lastly we have those 2 resource management tasks where I created a pool and added this to the pool. Okay, so now the important thing here is the admin service is now running. So I can actually go in a browser. Okay, now remember I have started the admin service on this first node, right? This is the first node. So therefore I have to go to this IP, right? In a production scenario, okay, so in a production scenario, we will have admin services running on all the three machines, so that in the case this machine is down, you still have a access to this web GUI. Okay, So this is the web GUI, right? So I had the private IP and then the port, the HTTP port, right? We set this port when we created the make boot config file 5001. And so you can see here right away that there is a data center which is called West, and there is a storage node, and this is the IP of this machine. So remember, storage node is a machine, and the admin service is running on this machine. That's all. Okay, we have not started any replication node processes, right? These are the master node and replica node services. This is the actual service. So we have not deployed anything else. We have just deployed this first storage node. Okay, so let's deploy the other nodes. Okay, so if we go back to our steps, we have completed these so far. Okay, now the other step is just adding other storage node agents to this data center. Okay, so I have it written here in clust sh. Okay, so again, one line commands. The only reason why I've added it in a script is it's easier for me to walk through rather than typing it online. Okay, so here it is. So first command is this is exactly same as the command in the previous step when I deployed this, when I added storage node to the data center, right? So I'm saying deploy storage node to this data center 1, where the host is now node 2. So this machine, I'm going to add this machine. Okay, I'm going to add the third machine here in this command, node 3. Okay, and then I add these nodes, node 2 and node 3, to the storage node pool. Okay, so that's what these commands are doing. Pool join sn2 sn3. Okay, now once I've done all this, I will deploy the topology. Okay, so final step, create and deploy topology. So in the topology, so as you know, right, topology is the layout. Topology is this layout. So you can have multiple topologies, right? Today you can have 3 machines, or tomorrow you can have 4 machines. So whenever we create a topology, we give it a name. So I can refer back to the older topology. You can even revert back to the older topology. So that's what I'm doing here. I'm saying topology create with a name, with the pool, right? So that this is where the resource management comes in. I'm saying that use all the machines. Use this pool, which basically means use all the machines in this topology. And then partitions. Oh, this is the number of partitions. Okay, so remember static hashing. We cannot change the number of partitions. These are the hash buckets. So I'm saying that for this topology, the number of partitions is this variable. Okay, whatever I have set it, and you should set it to a large enough number. 100 or 200 is a good choice usually. This will create the topology. Okay, so running this command is going to create this topology. And then running this final command, which is deploy, is going to make it functional. It's going to activate it. Okay, so let's run this thing. Okay, so the first thing is node 2 is deployed now. It's deploying node 3. Node 3 is deployed. Storage pools added. Topology created with 150 partitions. Okay, so I use the number of partitions as 150. Okay, and now it is activating the topology. Now, in fact, we can even see this in real time. So, see, you see this? So when we saw this before, the only thing that was available here was this storage node 1, and as the topology is getting deployed, we see that the topology browser is changing in real time. Okay, it's still getting deployed. Boom, perfect. Okay, so it's deployed, and you can see, right, this updated on its own, and now it is giving you the whole picture. Now your database is functional. So it is saying that you have 3 machines in your data center, 1 data center. We could set up multiple data centers. In this case, we have 1 data center West. We have 3 machines. Each machine has 3 replication nodes. Okay, one of those machines is running an admin service, so that's why we are able to see this here. Okay, and then this part here tells you about the shards. Okay, So RG is our internal development terminology for shards. RG is replication group, which means shard. So this is saying that you have shard 1, shard 2, shard 3. Okay. Now another cool thing here is when you come here, you can see where, on which machine this replication node is placed. So notice that the 3 copies of this shard, right? These are the 3 copies of the 3 replication nodes inside this shard. Each of them is placed on a different machine to maximize high availability. Okay, and I did not have to set this up, right? When we were setting this up, I never told it specifically to put this replication node on this one, this replication node on the other machine, right? It does it automatically. It automatically maximizes the high availability of your cluster. So when I told the utility that I have 3 machines, each of the machine has capacity of 3, it will automatically take care of this distribution. So there is no chance of a manual error where by mistake you place 2 copies on the single machine. We have made it very easy. Okay, so now the cluster is up and running, right? So 5 minutes, that's all it takes. Now we can look in the cluster. Notice that it doesn't tell you where is the master. So it doesn't say which one of these replication nodes is the master. So we can look at it here. We can go to the admin shell. Okay, so this is our admin shell, right? This is where we run all these commands to set up the topology and everything. This shell. In the admin shell, if I do a ping, it pings each of the machine and it tells me what is running on that machine. Okay, so it says here that machine 1 has 1 master, machine 2 has another master, and machine 3 has the 3rd master. Okay, now remember, in this example, right, in this case, when it's saying master, replica, replica, these do not belong to the same shard. You can see it here. Master is from shard 1, RG1, replica is from shard 2, and this replica is from shard 3. So it mixes it up to maximize the availability. Okay, now let's do some fun activities. I'm going to shut down part of the cluster and see what happens. Okay, so you have this cluster running. Okay, let's say we lost machine 3, so the whole machine goes down. Okay, so one of the common questions people ask is, oh, this is a master slave, so that means that if the master goes down, then you lose high availability, right? But that is not true, right? When the master goes down, the other 2 replicas are going to elect a new master. And this election happens in milliseconds. Okay, so practically speaking, there will be almost no effect on the application. So let's try that. Okay, so I am here on machine 2 and machine 3. So let's shut down machine 3. So again, to shut down, I have already created a script. I will just show you what it is. It's called stop SNA, but it's a 1-line command. Right? So it's nothing complicated. It's just stop. That's it. The utility is stop, and it will stop the storage node agent. Okay. So let's run it. All right. So the process is gone. Now this will automatically update. So let's wait for a few seconds, and this is going to be updated. In case you have load on the database where you're making calls, you're making read and write requests, then we pass this information piggybacking on those read and write requests. Okay, so it's not like an extra call to the application driver, right? So see, I'm now getting error messages. Storage node 3 is unreachable. Okay, rep node 3 is unreachable. Okay, so basically the whole thing became unreachable, right? The storage node became unreachable, and the 3 replication nodes became unreachable. Okay. Now let's go back, right, and let's do another ping. Let's see what happens, because now I'm worried, right? This master was on this 3rd machine. So this means that my RG1 master is now unavailable, right? That's what you will think. So your first shard, you cannot write anything to your first shard. Okay, but that is not true. let's see what happened. So now, right, this became unreachable. Okay, but see what happened here. Right here, this guy from the RG1 group from the first shard became the master. Okay, so now you have a master. Now two masters are running on the same machine, and then one master is here. You can still do your reads and writes and everything, even though you just lost 33% of your cluster. Right? You lost a full machine. Lost 33% of the cluster. You're still up and running. No problems. Now, just for fun, let's also stop this one. Okay, so I'm going to stop this second machine as well. Let's just see what happens. Okay, this browser should update in a few seconds. As I said, if it's a real scenario where you are actually reading and writing data, then the topology information, the cluster status, is passed on with every request as part of the metadata of that request. So this is taking a second, but just because I don't have any load on this database. Okay, so boom. Okay, now we get it, right? This thing is down. This thing is down, right? The whole thing is down. Stairs node 2 is down. The 3 replication nodes are down. Okay. Now let's see what happened. What happened to the processes? Okay. Now notice 67% of your cluster is down. Okay, this is a calamity. Even then, you still have sort of a functional database, right? The older master, the master which was on the first machine, this belonged to RG3, which means this was the master for shard 3. This is still running. So you can still do reads and writes on your shard 3. The other two machines here, right? Notice that they did not become the master. Okay, when we shut down this machine, then we saw that the other machine became the master by itself. In this case, the other two machines did not become the master. The reason is we need a majority to elect the master. Okay, so in our shard there are 3 nodes, which means majority is 2. Okay, so we go back here, right? So in this shard there are 3 nodes, majority is 2. Shard 3 nodes. Okay, so when we shut down the one of the machines, right, the other 2 nodes were still alive. Okay, and this is because of the placement. The way we have placed these replicas is this goes here, this goes here, this goes here. So even when this went down, right, in our first scenario, when Rn3 is down, Rn1 and Rn2 are still alive, and so they are able to elect a new master. And as we saw, the master was on this second machine, so Rn2 became the master. Okay. In this scenario, what happened is now 2 machines are down. Okay, so now for Rn1, even though I have a node which is alive here, right? This, you see this RG1 Rn1 is still alive. But this cannot become the master because it doesn't have the majority. 2 other nodes are dead. Okay, what this means is you cannot do writes. Even in this catastrophic scenario, all it means is you cannot do writes. You can still do reads from this. So you can still do reads from your shard 1 and even on shard 2. Okay, from this machine. This machine is still unknown because, as I said, it cannot be the master without majority, but they will still service read requests. Okay, so that's it. This is the end of the tutorial. This is all I wanted to cover today. You saw how straightforward it is to install and deploy the database on AWS. Basically, these are the steps: 1, 2, 3, 4, 5 simple steps, and your database is up and running. We also saw a little bit of HA in play, right? So we shut down one machine and we were still fine. The master relocated, and then we shut down another machine, and then we see that only one machine is alive, and we have one master and two nodes which cannot be the master, right? In fact, if you start the service again, okay, you can start the service again. Okay, so if you start the service again, you really don't have to do anything. It just automatically joins the cluster. It already knows that it has to join the cluster. Okay, so you will see that this thing gets updated automatically. So I just started the machine again, right? No recovery or nothing like that, and boom, 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 starting. Everything is back to normal. Okay, get this. All right, you do the ping again and see. So automatically everything is back. Okay, back to where it was. All right. And in fact, what has happened is because in one of our scenarios we failed this machine and there were two masters on this machine. This machine still has two masters. So this again, the database takes care of it. So the database it will notice that there are two masters here, and it will do a rebalancing, and the master will actually move to this machine. Okay. See what I'm saying? Right here. Okay. So it will notice automatically. So I didn't have to, as an administrator, I didn't have to fix anything to move this master. Okay. Automatically in a matter of seconds, the master relocated to the new machine. Okay. And that's really the power of Oracle NoSQL database. We try to make it really simple to administer. Okay. So thank you guys. That's all I had today. Check out other videos of Oracle NoSQL database. We have some really nice videos on data modeling and other videos on deployment as well. Thank you.